Welcome at the Masters of the Code channel. In today's video, I want to show you on the practical example how you can configure Influxdb with Grafana and also the container responsible for collecting data using Python script. And I want to show you that on the example of my photovoltaic installation. So it will be longer video. I will also tell you a little bit about my installation, and I also want to show you the vendor application for the inverter, so you have the full comparison how well it works and what you can do with approach which uses Grafana. So I would like to start with the nice example for the Grafana. So I will show you the whole working solution. I will first change the time period for last 6 hours. So I've been able to achieve that nice graph for my installation, and I've been able to achieve it adding HTML graphics plugin to Grafana. So I've prepared that background first, and then I put those animations in CSS, and also I combined it with proper queries for Influx database. I have to refresh the page. It sometimes works like that, so I need to refresh and hit the edit once again, and right now it works. And also, okay, so let's see here some example. So we have here those queries in the old style, SQL-like, you could say. Of course, I also use the Flux queries for more complex queries, but I can use both, and it's nice feature. And I also use Influxdb in second version here. So you have queries to get that parameters like active power and other power parameters, for example, how much energy is being produced by your photovoltaic panels. And then using that plugin, you are able to put some CSS, as you can see here, and also you are able to put some basic layout in HTML. And the most important part, you have it here in the JavaScript, is responsible for changing those div blocks and to supply values from the Influxdb queries. So it's all done dynamically. And also I have that scale part because it wouldn't scale nicely under Grafana panel, so I need to add that one in CSS, and you can see it even here when you have, let me find it, you will have it here or in the JavaScript part. So maybe let's get back to the JavaScript part. Yes, that transform property for the CSS style here, so we can use scale, and it's nice scaling for the whole graphics here, and without it wouldn't look so nice. And it's especially important when you also want to be able to view it on the phone, for example. So you have that graph, and on that graph I have those information when my inverter started for the current day, and of course the shutdown time for the previous day, or if it's correct hour like in the evening, you can also see the shutdown time then for the current day. So I have also information about voltage on each string connected to my inverter. I will also tell you a bit more about whole installation details in the next part of that video, and you can also see the power, the current energy production from panels, also the production after the inverter, because you never have the inverter which has 100% efficiency. So you can see the smaller value here, of course, and then you have the power which is needed by all devices in your household, and of course the power either exported to the grid, or when that value is greater than power which is being produced by the inverter, you would see arrows in the opposite direction, and it would view here the power collected from the grid, imported from the grid. And what's more, I have those statistics. So those statistics are prepared for the whole time. So I've installed it, the whole installation, at the beginning of the February, but I've also needed some time to prepare those statistics, so I'm collecting those data only for like 10 days. So those values are counted for that period, of course. So if I would see that total energy production, for example, in the vendor application, it would be greater value than there. So the most important value here is the energy balance. So what it means, it shows us if we need to pay some fee to the energy supplier, or we are on the plus, and when we are on the plus here, it means that we won't pay anything, and we also have that additional capacity of energy we can spend in the next period also. So of course, for now, because it was winter here and the production wasn't so good in each day, for some days it had been very small, like few kilowatt hours of energy, and of course for some days it was great, like for example 24 or 25. So it's like that. And also I have that second value here, so it's the total cost of energy for that period. So it means that if I wouldn't install the whole photovoltaic installation, I would need to pay 139 Polish zloty to my energy supplier. And of course, when you subtract from that value that one, it gives you the real benefit from the photovoltaic installation. So even if it was the winter time, you can see that that benefit, because it's greater than 100 Polish zloty, even for those few days. So if you are interested and want to get the knowledge how to build such graphs, how to process the data from the Influxdb, stay tuned, and also remember to subscribe my channel, because I'm going also to put even more interesting videos in the future. And also remember to hit the bell icon to stay notified about my future videos. I moved to my garage because I have all devices for my photovoltaic installation located here. I won't show you the roof part. I can only tell you about it because I don't have easy access to my roof. I would have to put that ladder to show you that part. Maybe I will find some photos to show you that part also. So on the roof I have 22 Longi 450 watts panels, so the whole installation is rated at 9.9 kilowatts, and I'm limited by the area of my roof. If I would have greater space, I would put more panels. And the reason why I've chose to do that installation, especially in the winter at the beginning of February, is I've also bought last year on August soft-tap jacuzzi, which is only rated at 800 watts, but it needs around 8 to 12 hours to heat the water, and it's especially greater time in the winter. So for that whole period, my energy bills increased 3 times. So I've chose to do the whole installation even while there was still snow on my roof. But the important thing is, when you can get rid of the snow while you're installing the construction which supports the panels, it's fine. It doesn't matter if it's winter or any other part of the year. So I have it done, and I also use the half-cut technology panels. And the half-cut technology panels have that benefit that even if one panel is covered by shadow, some obstacle like, for example, chimney could project shadow on one half, the other half can operate independently. If it wouldn't done in half-cut technology, the whole panel would produce lower amount of energy. Also, I have installation oriented toward west and east because I have very low angle for my roof and it's the optimal installation. So I have two strings. The first string for the east has 10 panels and the second for the west has 12 panels. And that string means that panels are connected to each other. So every panel is connected to the previous one and the next one. And additionally, I've chose also to use optimizers and chose to use it for each panel. Of course, it increases the cost of the whole installation, but without optimizers, when you have the whole panel in any string covered completely by shadow, all other panels will produce less energy. So to maximize the energy output, the optimizers are really good choice. And also optimizers gives you that additional ability to monitor your installation better. Of course, you need proper inverter to do that and software on the inverter, but you are able to read energy production from each panel separately and also the voltage, the current. So you are able to check if some panel needs to be cleaned, for example, or even replaced because you don't see any energy output for some greater time. So you have those panels and those two strings are connected through using 4 cables and also fifth for ground through my chimney. It was the easiest solution and all that is connected to that box you can see here, and I have also 2 surge protectors. So that one are responsible for protecting DC voltage on the input of the inverter, and of course you have also the AC surge protector at the output of the inverter. And what's more, I've used that Huawei Sun 2000 10 kilowatts inverter, and as you can see, that inverter has only one big heatsink at the back, and that inverter also doesn't have any LCD or OLED display, and it's good solution because you will have less issues with those parts, and you have to remember that you want that inverter to work as long as possible, so at least 10 years without any issues. Also, that inverter has 2 Wi-Fi cards, Wi-Fi interfaces. So first at the bottom you have that additional Wi-Fi dongle, which is used to connect that inverter to your home network and by it to the internet, and it connects to the Huawei cloud when all data are being collected and stored, and then you are able to connect through the Huawei application from your phone or go to the portal and see nice graphs from energy production, how much energy you also export to the grid, import from the grid, and also other parameters. I want to show you also in that box, you have that simple meter with the simple LCD. It allows you to get basic parameters like energy output, energy import, energy export, and voltages and currents. So it's here because, of course, that Huawei inverter lacks that LCD display, and it's the good option to check some basic parameters while you don't have your LAN network or internet operable. So it's good addition. So let's get back to that inverter. You have also that second Wi-Fi interface, and that second interface acts like access point. So you can connect from your phone, and using application from Huawei, you can configure that whole inverter for the first time. So you are able to configure it even when you don't have access to the internet. But you have also that Modbus service. It's the standard protocol and you have it enabled on port 502. So when you connect from the other device, you are able to get interesting data on that port. And that is the reason why I use that mini D-Link router, DIR505, is the old device, but it's perfect for that. I've put OpenWRT there and also put SanDisk Cruiser UltraFeed memory 64GB flash drive. And I've configured it to use that flash drive formatted to ext4 file system as the overlay for Squash FS. So I can surpass the limited built-in memory that way, and I'm able to install python3 and also Modbus modules and tap to that inverter Modbus and collect data and write it to that flash drive. So I'm able to collect data. My script does it and saves it in JSON format in subdirectories, because I'm creating subdirectories, each directory per day. So it's more efficient to gather that data from other devices later, because I've also installed a very secure FTP daemon here, so it's lightweight and I'm able to tap to that data from other devices, and because those data are located in those subdirectories, it performs faster, because for example I can only ask and list one subdirectory for current day. And you can imagine if you would have some greater period like 10 or 20 years, it would take some time and it would be inefficient. And of course that 64GB memory and amount of data, it should be able to gather even 10 or 20 years of data, which is collected twice a minute easily. And also it can pass that limitation that Modbus protocol and that inverter has. That is, only one device can be connected to that Modbus 502 port at the same time. So it can surpass that, because I can forward that port from that D-Link router and use it from other devices. So I can either use it as a cache and tap to those files through the FTP, or I can forward that port and use it from multiple devices. Of course, I'm still limited, and if I would like to reconfigure that inverter from my phone and the application provided by Huawei, I will need to power it off or disconnect that D-Link router to be able to do that. But of course you won't do that every day, so it's perfectly fine. And that D-Link router has only one Wi-Fi card, so I had to also connect it with the cable to my other old TP-Link router, and here I've installed DDWRT and tapped it to my home LAN network as a client. So as you can see, that way I'm able to tap to those data from my LAN network, and I want to do that especially from my NAS device, where I have that container to collect data from that D-Link router and supply it to Influxdb container, and then I'm able to present those data nicely in my grafana container. Of course, I will also show you that later, and I will also show you the whole Huawei solution and the application. We will be able to see in comparison how original application performs compared to my own monitoring solution in Grafana. Now let's see some photos from the roof. Now I'm going to show you that Huawei application that you will get out of the box when you buy Sun 2000 Huawei inverter, and it uses data gathered in the Huawei cloud. So after starting it, you have that daily energy at the top part of the screen. So it's the amount that your installation had been able to produce from the midnight, so for the current day. So as you can see, it's in the morning, so it had been able to produce 1.32 kilowatt hour of energy so far. Then you have also the current power, so how much energy your photovoltaic installation produces right now, and also that lifetime energy, so it's the cumulative sum of produced energy from the starting point, so from the point where the installation had been installed and initialized. And below you have also the list of all places when you can have photovoltaic installations. So I have only one place, so let's tap it, and on the next screen you have some more details. So once again you have that daily energy here and lifetime energy, but also you have that daily consumption, which shows you how much energy your all household devices had consumed from the midnight. So it's the consumption for the current day, and also you have that self-consumption parameter, so it shows you how much of that energy currently produced by the inverter, by the installation for the current day, your devices had consumed. And below you have also that nice and simple graph, so you can see the photovoltaic panels at the top left part of that graph, also your inverter and power meter, and beneath you have also two additional parameters, export and import. So the export shows amount of energy that had been exported to the grid, because there is also some period when you need less energy, so your devices will consume less energy that is being produced. But also you have the opposite situation also, especially at night, when you need additional energy from the grid. So it's the import situation. So let's get back to that graph and tap to the on those panels. Here you can see that simple layout, the simple map of your panels, and that is the exact layout how panels are located on the roof. And you can see here the cumulative amount of energy that had been produced by each panel, also for the current day from the midnight. And you can also tap on each panel here, and what you can see here, that those top panels are oriented toward east, so you can see that they've already produced more energy than panels located oriented to the west, because it's the morning. And also you can see that I have that chimney, one of my three chimneys, located around those two panels. So you can see that panel which produces only 0.09 kilowatt hour of energy, and also the second one which only produced 0.03 kilowatt hour so far. So we can tap at the panel that, for example, produced the most of the energy. So for example, the upper left one, and on the device, so we can see more details. Output power, of course, we have also the total production of energy for that panel from the installation point for the installation, and also other useful parameters like current voltage output, input voltage, current, and running status. And we can also get back and tap on that panel which produced the least amount of energy, so that 0.03 one. And here you can see also the difference. The total it's not that different, but you can see current output power, which is lower. And maybe let's tap on that panel also, which produced only 0.09 kilowatt hour. And here you can see greater difference, because in total that panel produced around half that energy of that most top panel on the left, for example. So it's also really great for checking panels that needs to be cleaned, and also you can see which panel is, for example, broken or needs to be replaced, and you don't even have to go to your roof for that. And it's the real benefit for the Huawei application, because for now you can't get those data, that map, using your own solution. So in my Grafana solution, that is only one thing I'm not able to show. Let's get back to that previous screen. So on that graph, we can also tap on the inverter, and here you can see the voltage, the current for each string, PV1 and PV2, and also you have voltage and current for each phase, as you can see in the upper part, and some other useful details. Let's tap also at the power meter, on the power meter, and here you have also other useful parameters. So those parameters are being refreshed every 5 minutes. And beneath you can also see those export and import values. I've already told you about it. And also you have that more detailed graph for the current day, where you can see the production, consumption and self-consumption, and we can magnify some range, some part of that graph also. And here is the interesting situation, because you can observe that gap here. So we have gap here. It's caused by internet outage. It also can be caused by some issues with Wi-Fi connection from inverter to the home network, but more probably it's caused by performance in that specific time of the whole Huawei cloud. But it's not a big deal, of course. That gap doesn't impact that cumulative sums, so it doesn't impact that import export values and the current production and other counters, because those values are implemented as counters registries in that inverter. So it's enough to get those values even few times a day by Huawei Cloud, and you are still able to get the correct data. You can also switch the period here, so by 1 day, or you can choose it from here also. You can choose some other day, and also you can see these statistics in the monthly period and also annual period, and we can also magnify here. Let's check also annual period here, and let's get back. And beneath that graph you have another one which should show you the energy and revenue statistics. So it's quite similar to the upper one. Also you have that lifetime tab here additionally, but you won't get the real cost, the real balance of your installation here, unfortunately, because it's not that easy. It's some downside of that application from Huawei, because in different countries, different energy suppliers have different terms. So for example, here in Poland, when you have installation that is less than 10 kilowatts, so that is also why I have that 9.9 kilowatts installation. When you export energy to the grid, you can only get 80% of that energy back for free. And if you have more powerful installation, more than 10 kilowatts, you can only get 70%. So it's the difference, and it works differently for different countries. So it's hard to implement in such application, and that is why I've been able to implement that in my own Grafana solution, because I'm able to put my own queries there and also take that 80% into account. And beneath those graphs you have those you have that environmental contribution, so you can see how much standard coal you've been able to save using your photovoltaic installation, how much you've been able to reduce the CO2 emission, and also the equivalent tree planting, so trees that would need to be planted to absorb that extra CO2 emissions. Let's get back to the grafana. So we have those values like CO2 saved. So how much CO2 emission you've been able to reduce by using your photovoltaic installation. And of course you have that total energy production. So I've been able to produce from the starting point 219 kilowatt hours of energy here, and we have also that value how much standard coal we've been able to save. So that amount of coal would be needed by energy plant, for example, to produce the same amount of energy. And we have also here trees planting equivalent, which means you would have to plant that much trees to get rid, to compensate that CO2 emission if you wouldn't produce that power in your own photovoltaic installation. And we have that last value here, so it's the daily energy productions also. And if you can choose edit to see queries here, those queries are more complex, as you can see. So I'm using flux queries here, so you can see that we are getting overproduction in short, and we are also getting the energy collected from the grid. And I need also to put that value here, that 0.8, so 80%, but it means that I'm able only to get back 80% of energy I've exported to the grid, to the energy supplier. And also I have that parameter, so it's the cost of 1 kilowatt hour of energy here in Poland. So I've put it to the variable here in Grafana, and I can show you also that for that dashboard we have that variable. So we can, for example, click settings here for the dashboard and variables, and we have that value here. It's a really good idea to put that in the separate value, because that fee can change quite often. So if it would be put to that separate variable, I would need to update those queries each time. So that is the query. I will also tell you a bit more later about those flux queries. So I will show you how you can analyze or prepare queries for graphs in Grafana from Influxdb. So for now only short introduction. And here I also have, if I change the period to, for example, last 30 days, I will be able to see that energy balance per day. And what I can see here, that I have days when I exported really huge amount of energy, like for example here, but I also have days when I needed to import really huge amount of energy from the grid. I have a soft tap jacuzzi in my garden, and it needs 800 watts of power, and I've also changed the water, so it needed to be powered on for more than 24 hours, so 1 day and a half, something around that. So it is visible here on the minus for that day. Of course if it would be in the summertime, it could be covered by the current energy production, but because it's the winter time, the amount of the production is not that great yet. And next we have also the graphs for that CO2 savings, and also tree saved, but weekly graph here, and for inverter states. And that graph we can magnify some range for that graph, and we can see those states. So you can see that of course at the night we have no irradiation state, and then the inverter initializing, and tries to detect the irradiation. And if it succeeds, so it can switch to the on-grid state. Of course, it's not always like that. It's good to have it monitored. And also in Grafana, you can connect it to some alerts, for example, so you can put the alert to be sent on your email, and in that situation you have nice monitoring, and you have information that something is going on and you need to check it. And also you can put the alert if inverter won't start for the some time periods, because on the next graph, for example, let's choose last 30 days again. I have those states for those start times and shutdown times for each day. And as you can see, from winter to summer, it will be longer periods, of course, but you can set some alarm, for example, if that inverter won't start till, for example, 9 or 10 a.m. It's something wrong probably, or it needs to be restarted on something like that. And next we have the energy statistics, and those one should be analyzed in some shorter period, like for example last 12 hours. And you can see on that one that we have that green part, so it's the photovoltaic installation production amount of energy, and that orange part, which is the current consumption in your household. And the difference between those two parts can be seen. So if the green one is higher, is above that orange one, it means you have overproduction, so you are exporting energy to the grid. And the opposite way is you need to import, especially at night, you need to import energy from the grid. And you can see when you hold the cursor over the specific point, you can see the detailed values also. And the same you can see for the each hour here. And also I have the daily statistics for that. And in daily statistics, last 30 days again, I can see that for each day. Also I have the statistics from the inverter temperatures here, and also voltage for each phase in my 3-phase installation. So you can see for that voltages, you can see that when you have less energy needed by your household and your inverter is able to produce more power, so for example during the day, it can be situation that of course that voltage will jump to, here in Poland for example, 250 volts, and that is the range when inverter will shut down. So if inverter will produce more energy, is the phase safe set for the 250 volts, because it can't be bumped indefinitely for that voltage, because it would cause your household devices failure that is covered by inverter. But also you can have the situation when that voltage will be lower, because you have that high energy consumption in your household. So in that case the situation will be opposite. You can also set alarms in Grafana and the email notification for that. And next we have the voltage for each string containing panels and connected to the inverter. And you can see that at the morning, for example, you have higher voltage and lower current, and that will change during the day. So it's also the nice way to observe the how the whole installation works. Next we have input power, which is input power before the inverter. So it's the greater value. It's the amount of energy produced by your photovoltaic panels. And next we have daily energy production also. So we can extend that period again, and you can see you have values for each day here. The same values for exported energy and imported, and those values are based on the different approach of data collecting, because those under graphs are based on the twice a minute collections of the data. So we are collecting each parameter, and we can sum it, and we can even extrapolate for the other period of time from those values, but it's not that precise as those accumulated registries. It's nice to get by minute consumption, production, etc., or even by hour, but not that great for accumulating during longer periods of time. That is also still work in progress for those graphs. So I'm trying to use those accumulated registries, which are kept in the inverter and allows you to get that total daily energy, for example, energy production, exported energy, and also imported energy here. Now is the part when I'm going to show you how to configure your Influxdb and Grafana containers under Docker, and also I will show you the configuration for Nginx reverse proxy to use it with Grafana when you, for example, want to use SSL communication, and also limit possibility to login to Grafana from admin user, for example. It's a good way, but I'm not going to give you the full configuration because I've already showed you in my previous video the configuration for Nginx. So I'm only going to give you the file with Lua script. Also, under that video you have all resources needed for that tutorial, and I have it all also located inside that influx_grafana subdirectory here. And also here you have file with commands which I will be using in that tutorial, and also queries for Influxdb in Flux query language. So is located here. I'm also going to open my virtual DSM. So let's log into the web UI. I will open File Station, 2 instances, 2 windows. In one window I will open the configuration, the previous configuration for Influxdb and Grafana, and in the new one I'm going to create new directories for the fresh configuration. So we will need the Grafana directory and also the Influxdb directory, and inside Grafana we need that etc Grafana subdirectory etc, and inside we need Grafana subdirectory, and inside we will need the Grafana ini, but I will need to start the container first to get the initial configuration, and then I will be able to copy that file from inside the running container. But we can also create the whole provisioning directory. Provisioning, here you can see. So provisioning subdirectory, and also inside we need to create some subdirectories. You could also skip that part, but then inside Grafana container logs, when you would type docker logs grafana, for example, grafana-grafana1 to be precise, you would get those logs, and in those logs you would see that those directories are also needed. So we will create also that subdirectories. So dashboards subdirectory, data sources subdirectory, notifiers, so notifiers subdirectory, and the last one, plugins. So plugins, and also you can see that we need that var directory here. So let's create var subdirectory, and inside we need the lib subdirectory, and inside we need the Grafana subdirectory, and also inside we need that plugins subdirectory, plugins, and that's the whole subdirectory structure. And for Influxdb, let's check that one. For Influxdb, we don't need any subdirectories. Those subdirectories will be created automatically, so we can skip that part. So now we should put the proper permissions. So for Grafana, we can check. So we have here some default permissions. It's not the correct directory, it's that one. So first we need to change the owner to the root user for both of those subdirectories. So own recursive root user, and let's do it for the grafana and also for Influxdb. So that is the first step. As you can see, it had been changed. And also right now I can cover the permissions part. So let's create the new rule for Docker tag, and I want to deny the access for that group. I've already showed those permissions and other stuff in my previous videos, so you can check them also. And we need to add the full access for the owner. You should also remember that right now the root is the owner, but inside the container you can have multiple users, so it can change. So it's the good practice to put owner here, so it will apply even if the user is changed from the root to other user also. So we need to allow full control for the owner, and the last change is to give everyone full control here. So everyone, like I said in my previous videos also, it doesn't mean that every user will be able to get inside that subdirectory and do stuff. No, it will also be limited by the parent directory permissions, so it's fine. So let's check the apply to subfolders also, and we need to do the same stuff for the Influxdb subdirectory. We can also see it here, but it should look the same like for the grafana. So docker tag deny, docker tag deny, and all of permissions. And also we need to add owner and allow full control. We need to also check that box here, and I don't have everyone here because Influxdb only uses root user, so it should work like that. Okay, so we are ready to start Influxdb right now, and I also give you that conf.d directory. It's inside influx grafana conf.d. It's that directory for that my manage.sh script for Docker. I've already covered it in my previous videos. You have also that script. You can get it from the previous videos. So right now I'm also only going to put the specific configuration for Influxdb and Grafana here. So it's really basic configuration for Influx, for example. So you only have that part for cleaning previous images here, for pulling new images here also, and for creating the Influxdb container. So you only need to put the one volume here, so mapping to the whole configuration, that directory I've just created. And also you have to redirect one port, and here you have the image for Influxdb. So let's start it. Oh, and I should probably check if I had deleted those containers. It's docker pso, and yes, it's correct. So I can put manage, update, and influxdb1 to pull the newest image and start the Influxdb container. We can also see logs, so docker logs with F option for Influxdb container. We can also check that directory. It's being populated, so everything works like expected. And also we should see, yes, that engine subdirectory, and also we should be able to tap to that web UI for Influxdb right now and do the first configuration. So let's get started. I will put admin here, test 1234 password, of course for testing purpose only, initial organization name, masters of the code, and initial bucket name. Let's put test here and continue. Quick start, we can skip it. So we are in, and what's happened, we can check it here. So we have that one test bucket created. It's the same like separate database in previous Influxdb version. So for example, in 1.8 previous version, you had the database, and we will also do the map of that bucket to the database name, so we are able to use it with old style SQL-like queries, also from Grafana. So we will do that, because without doing it, it won't going to work like that. And also we need to some other stuff, so let's do it. And for that we will need those commands from that file and influx section, and also we will need token and organization. So let's tap to the Influxdb container and start bash. And here we have that influx command, and v1 is the version of commands we want to run. So v1 means that we want to run some commands for the older queries style. So let's copy it and put masters of the code organization. And also we need token, and we can easily get that token from tokens. It's admin token, and copy to clipboard, and we can paste it here. So we can list those mappings, so mappings for bucket to database names for older queries, and we hadn't created any yet, so it's empty. So right now we can do that. So let's put the command, we can do it. So we have organization here, token once again. We will set it as default, so it will be treated as default database, and also we will set that policy to auto gen, and we will put the db name here, so it will be test database, and we need also the bucket ID, and we have it here under buckets, so we can get it from the test. Copy to clipboard and paste it here. And as you can see, we can also run that previous command again. We have that mapping done. You can also use the command to delete it. You have all commands when you put the first part. So influx v1 dbrp with help option. So you can see that you can also delete mapping by ID. So we will leave it like that, and we can leave the container for Influxdb right now. We can configure the grafana. So we have that in conf.d grafana subdirectory, the same as for the influx. So you have the clean and pull files as usual, and the create file responsible for new container creation. And also let's create the container to get the that ini file only, so we can create new container, and I will only put those minimal options. I won't put those volumes mappings, only those options. And we can start that container, docker start, and also we can see logs and tap to that container also. So we have logs, but we can also tap to that container to see if that ini file is ready. Let's check that etc grafana.ini file. Yeah, so it's ready. Let's copy that file only, docker cp. We need container name and that path, and we will save it under volume 1 base config grafana etc grafana, and we need that name of the ini file. And let's also check that it's correct here. Yes, it's correct, but I think that we need to check permissions also at that file. Yes, let's restore the those permissions and let's check again. As you can see, the permissions had been restored, so we are ready to start the grafana container right now. I'm going to remove with force, so I'm not going to stop that container. Let's remove it so we can start the proper container right now. It's being removed, so manage, update, and the name for the container. Let's also see logs for the new container, docker logs. We will see at the end if those permissions for those subdirectories are correct. So we need to wait till the end, and of course the HTTP service will be started at the end. And as you can see, there is one directory missing, so it's that one here. So we can of course create that subdirectory. Let's create that subdirectory. So it's here. It's etc grafana provisioning notifiers. Let's also see what we have here. Of course, because we have wrong name for that subdirectory here. So let's correct it. So it's notifiers, of course. Let's correct it, and let's restart the container. Let's restart and also tap to the logs once again. And right now it looks correct. Okay, we can also check if we need those, if we have those subdirectories populated, but not that one. We should check for now that var lib grafana directory. We have only grafana.db file for now, as you can see. And let's log in to our grafana also. If I remember correctly, it's admin. Yes, for the first login, and the new password says 1234. Let's change it. Okay, I will also check if the password is correct once again. Yes, it's correct. Right now we have the grafana container pre-configured and Influxdb container pre-configured, but we have no data yet. So for that we need third container to supply data using Python to that Influxdb. And for that we need to create some really basic container without any image for that presentation. Of course, for the production usage, you should create the image using Docker file and put that Python script. I have it here inside influx underscore grafana and populate.py. That script, it's the good starting point to populate the InfluxDB. So we have really crucial and basic components here. So you should put the script like that as the entry point to that container with Python when you will prepare Docker file, and the script should run in some loop indefinitely. We can prepare that container. I also have some commands needed to install proper packages, and I have it inside that cmds file. So in the Python data loader section, let's start docker run detach, and the host name will be Python loader 1. Name for container the same. It won't have any volumes, so and also any ports map. So we only need to put the Debian latest as the image here, and for the command we will use bin bash command sleep in running indefinitely, so with infinite option, and we can start that container in the background. Let's check if it had been started. As you can see, it had been started correctly, so we can also tap to that container right now. Maybe first we will also need that populate Python script inside that container. So let's copy that influx from that subdirectory influx underscore grafana, that populate script, to that container, and we will put it in the root directory. And now we can tap to that container. We can also check if we have it here. Yes, it's correct. And now we can put those commands here. So I will put all commands at once. So those commands will install the python3 and python3 pip, and also vi and other tools. So we will be able to also check with ps if it works. And then we will install the influxdb client module for python3. So let's start. So we have it installed. It also may look like really easy part, when you are watching it here, but it took me a while, especially when I've tried it for the first time, to figure out how to map it correctly. And those SQL-like Influxdb queries are really handy, especially using in Grafana when you just want some simple data and only get one measurement at a time. Of course, you won't get any complex data using those queries, but it's really fast and easy for the simple ones. It's good to have both functionalities at the same time. When we have it done, we also need to look at those commands file. So I have that section when I'm exporting some environmental variables, and it's because I hadn't put them when I started or created the container. So normally you should put it here with the E option and one for each parameter, each variable, but without it I need to use that export command inside that container, because the populate.py script expects those data as environmental variables. So let's put the IP address when I have my Docker host. So it's my virtual DSM, the standard port for the Influxdb. Here we need to put our organization name again, and for the bucket we should put test bucket here, and the only thing we also need to put is the token. It of course doesn't need to be the admin token, it's the easiest configuration for testing purpose, but for production usage you should also generate some other tokens. So after the export part we have those variables here and we are ready to start that script. But maybe first I will also tell you a little bit more about it, and also the nice feature in the Influxdb, you can also choose other languages, so not only Python, but I've chose Python. So let's see here, you can get the example code to populate data from here also. So you have that module installation and you also have the basic code here. It's a nice feature for starting point. Let's get back to our script. We have here some needed modules and that basic class and also the logging. So you can of course use it as a template in your own script, and that class is being written in the singleton template, singleton model. So it's designed only one instance of the object can exist simultaneously, because it's no point to have more instances. That's the first thing. And also we are initializing those class variables, those class fields inside the constructor here, and then we are supplying those environmental variables here, as you can see, using OS module. And the most important part here is that loader method for that class. So it's the method responsible for loading data to the Influxdb database. And of course in real application I would have also some FTP module and methods to gather data, or some other like Modbus, for example, to gather data from that source. But for the testing purpose I've prepared some random data, and also you have that, you can see it here, you have that time here. We are also subtracting -7 days and we are then adding the I variable, so it's being iterated inside that for loop in that range. So it's the range from 1 to 7 days, 24 hours and 60 minutes, as you can see. And we are importing those measurements. Let's pretend that we have the voltage A, voltage B, also the energy collected from grid, the active power, so the power produced in our installation, and cumulative power also. And for those first measurements we will use the rand range Python method. So we have range from 200 to 230, and we have that step, so it's set to 1. So we will have the random values from that range. And for the from grid and other measurement, I use that sinus function from the math module. I also use the rand range here, but in the way we will get some more usable data for that kind of measurement. That's it. It should load the data to the database. So we can start that script right now. And as you can see, we have log for each data point, and we don't have any errors. So it means it should be loaded. Let's check our Influxdb. Here we can type some string like voltage, for example. Check those two measurements and prepare some basic query. So for past 7 days, as you can see, you can also magnify some range and get back. And also it's really nice because based on those parameters, you can also get the simple flux query here in script editor. So as you can see, it's prepared flux query for that stuff I've just clicked in the UI here. So it's the nice feature. Also we have those other measurements here, so you can also, let's get back and put, for example, grid here. From grid, for example, and accumulated. Let's check that Python once again. Cumulative. Okay, so we should put cumulative here, and we can also see the graph here. So the cumulative is the counter here, the registry counter. You can see those increasing values over the time, and from grid is the example of the energy collected from grid. So it can change for every minute, every hour, etc. So we can leave that container right now, and let's see commands here. We have all stuff prepared. Also I can show you that you can easily install additional plugins, like for example HTML graphic plugin for Grafana. For that you need to tap to the Grafana container, and we have here the grafana CLI, which is able to, as you can see in that CMDs file, you can, for example, search for the plugin, not install one. So let's check for the HTML plugin, and then we can easily install that plugin. So it's the plugin HTML graphics. So it's being installed, but we can't use it just like that. We need to restart the whole container. So let's restart the Grafana container. Okay. Right now I'm going to configure the data sources for the Influxdb in the Grafana. It's being restarted, so we can proceed to data sources and we can add data source. So it's quite easy for the flux queries here, because we can just type flux to be able to distinguish those two sources for the same database. And we will choose flux here. Here we need to put HTTP, the IP address, and also standard port. We don't need any authentication here. We need only organization, masters of the code, and token here. So we can get that token from the data tokens. So once again, for the testing purpose, I will use the admin token here. Let's paste the admin token, test bucket, save and test. It should work. And right now I'm also going to add that other data source you can use for old SQL-like queries for the Influxdb. So once again Influxdb, and I will left it like that. So we will have only Influxdb in the name. InfluxQL, right? The address once again. Nothing here. We will need custom header and also test database. and user. Okay, let's put admin and the token here, and I will put that authentication. It should be, if I remember correctly, it should be like authentication here with that token space and actual token here. It should be authorization header. So we should put authorization here, authorization, and we have token here, space, and the actual token, and it works, as you can see. So we can get back to the home. We can, for example, create the new dashboard here, new dashboard, and the new panel also. And as you can see, you can choose from two data sources. So for Flux queries, the more complex one, you have that one, it's default. But for older queries, you can also choose the Influxdb data source. We are able to, for example, let's put voltage here, and we can use time series, for example, for that. And we can also add another query. So we can also add, for example, voltage B. As you can see, with two queries, you are able to get two measurements in one graph in Grafana. And we can also change the name for the graph to voltages, right? And apply. So as you can see, it works. You can also change the time period, etc. For the easy graphs, you are able to use it the easy way like that. But for the most complex, more complex queries, you need to use the Flux language. For that, I will also show you that file with queries. You can also use it because I have some example queries here. For example, for the grab like that, let's add the new panel, grab, we use bar grab, we will use bar grab, and put the title here and the Flux query. As you can see, it's already default to Flux, and we will paste that query, the first one, here. Okay, we can check it, but it's not working. Okay, because we have that basic bucket, but I've used test bucket here, so we need to change the basic to the test, and it will work. As you can see, it works. We can apply. So for last 7 days, we have some example data. Let's get back to the edit. Also, I can use that script editor from Flux Web UI to also see and test that query. And here you have that option with graph, but only one measurement. So you are able to put the one measurement here. We have only one, so it's not a big deal, but for multiple measurements, you are able only to see one of them. In Grafana, you are able to see multiple measurements at once and one graph, but you are also able to switch to the table view, so you are able to debug those queries. Okay, so let's get back to the Grafana also, and let's talk some more about that query. We have that additional modules like in Python modules in Influxdb, and inside those modules you have some additional functions. In that one, for example, we have that add duration function in that experimental module, and that add duration function let us add some period of time, so you can have different units. Of course, we are adding or subtracting in that case the 1 day from the time value here. Of course, it will apply to the whole series, to the whole result of the original query. So we are subtracting the 1 day. You could also put the M for minute and H for hour, etc. for other units. And we can also use it inside one more execution. So you are also able to, of course, nest it like that. So you are able to, for example, subtract 1 day and then subtract, for example, 5 or 10 minutes if you need. So you are able to put it like that. And also in that we always use from to specify the bucket we want to query, because it's not only query. Here we need some variable. We put that variable, and results of that query are kept in that variable. And also you have that part that specifies range, and the minimal range construction you are able to use is only to use the start without the stop, for example, and you are able to put the hard-coded value, of course, here also. So for example, minus 10 days or something like that, and do query. But of course, usually we have some dynamic variables here, and you also have those dynamic variables when you are preparing the query the automatic way in the query builder, like I already showed you. So you get those basic commands created for you, of course. Let's get back to the grafana. So we have those dynamic values, and also for the stop, as you can see, those values will scale when you will, of course, choose the different period. Like for example here, from and to, those values will be put here in the range method. Next we have that filter, and that filter acts like select in the SQL-like queries. So that filters fields, or in that case measurements. Of course you can also filter by some other tag used inside the Influxdb, because you can also add additional tags when you upload data to the Influxdb. And as example, I can show you that populate script, and you can see that we have that tag unit, for example, which also can be used to filter those measurements. You can put any number of tags you like, and then you are able to filter by those tags here inside those queries. For example, R, and inside those parentheses you can put the underscore unit tag, for example. Okay, and of course you are able also to use and or operators to put more stuff here. And then you have that map function. That map function is the similar like lambda function in Python. So it's the function that will iterate on all results from the query and will do some operation. So in that example, it will do operation on the time field. From that perspective, when you have some bigger data range, you should also use something like that aggregate window sometimes before that map function. It will perform much better. So you have that aggregate window part, and that function aggregates those values. In that case, we get last value for each day. You won't see any more detailed range here, like for example for hours or minutes, because we are aggregating for one day and we are using the last function here. For other measurements, you have also the min function to get the average value. You are also able to get the max min values, for example, and other aggregate functions. And also you can just calculate units also, for example, in that map function. And as example, I can tell you that you can calculate kilowatt hours, and when you want it in the daily period, you just need to divide by 60. So you have that aggregate window, and we have it later also again, but in that specific example we have those dynamic variables once again, because when you have some data range and it's big enough, so when you have, for example, few months, it would be inefficient, and also it's the limit of the grafana. It can't put or graph any number of points from the performance perspective, so you need to get rid of some of those points. So we are aggregating once again, but on that first aggregation. So first we have daily aggregation, and then we are aggregating and we are getting the average value here, but for the specific period of the window set. So it will perform no matter which period you will choose. So you can even choose period which will consist a few years, and it should work in that way. And also you can see that in that query I have those two sections, because what I want to get here is that cumulative power, but the cumulative power is the measurement of the produced energy, but as a counter that counts indefinitely. So you are adding value each time you are updating that registry. So for example, you have some value from the previous hour, and the next hour will have the greater value because you've been, for example, able to produce some more energy in your photovoltaic installation. And of course, there will be the night period when that value will stay at the same level, but it will increase indefinitely from the starting point of the installation initialization. So to be able to get that specific for in that case production for one day only, we need to get value to the from the previous day. So that is why we are subtracting that one day here, but we also need values for the current day, so not subtracted like here. So we have it in the next query, but we need to combine those two queries. And to do that, we are able to use the join. It's similar to the SQL-like join, but it has also some limitations. And the limitation here is we can only join two queries, not more. But we are also able to put some, for example, test1 variable here and do the second join for other data set, for example, and join those two new variables like test1, test2 or something else. So you can pass that limitation that way. And you need also to specify by which field you want to join those data. So we want to join using time field, and then we are using once again that map function because we have value from the first query and value from the second query. And as you can see, we would have underscore value if we wouldn't use join, but the join method adds here the name of the variable used in that join. So it adds that name to the name of the variable. So we have that value g acc1 and acc2. You can subtract those two values, and then we are able to get that value per day. So as you can see, it works here perfectly. Now I'm also going to show you some other examples, so we can use some other query. Let's add a new panel here with the proper title. We will use bars also, and we can put the query from here. I will also need to change that basic bucket name to test bucket used here, of course, so it should work. Yeah, it works. Of course, we will be able to see more in shorter period of time, and even we can magnify some range. Of course, you have the example random data here, so you should take it into consideration when you analyze that kind of query. It's better to use your even own data to test such queries. And here we need to get two measurements. So we need to get, as you can see, the energy taken from grid, some imported, and we then need to round it or standardize it. So we have data in 1 minute granulation. So we are using the min function to get the average value, and we also use that aggregate window function with the window period, so it will be put from the grafana range here. And the second measurement, it's actually the same, so you can see that the only difference is the name of the measurement. So it's the active power, so power produced by your installation. We are once again using that join function and the map, and as you can see here in that example, you are able even to use the if than else inside those queries, which is really nice because you are able to process that whole data even more. You can put some new variables here in that map. So we had only the, as you can see, the PM1 and the AP1 values from those original queries, but we are able to calculate, for example, overproduction from grid and the energy which had been get by the household devices here. Of course, as you see, you have the random data here, so it's not that intuitive, but you can see how you can use those queries. So let's see the third query right now. It looks like a simple one. So new panel title, and let's paste the query here. So we have it pasted, and let's change the bucket to the test one, and it should work, and it works. So it's the really simple query. As you can see, I have that thing I've already told you about, that OR here. So I have two measurements get by that flux query, and also when you have that query which can consist more fields, more data, you have that yield directive when you can specify the field that should be put on the graph. But also you have to remember that you have, when you have more measurements, it will apply to each measurement, and that is why you don't only have one field here but more fields, because that aggregate window method works at each measurement independently here, and both iterations produce that mean value. So using yield field causes that outcome that you have both values on the graph. So as you can see, you can achieve really complex queries using Flux, but of course for more simple queries, the InfluxQL, the old style SQL-like queries, are also usable and better to use. It also had been really long video, I know, but I've also wanted to cover a lot of topic. And one more thing, for that Nginx reverse proxy, you have that configuration in that grafana.lua file. So it's the configuration for two example users, masters of the code and the viewer one user. So let's imagine here, when you have users, save dashboard test one, for example. So let's save that dashboard, and we can go to the users, and here we can, for example, add masters of the code user, and the same name, test 1 2 3 4, for example, and the user has only viewer permissions by default. So as you can see, we have that user, and we can also, for example, put the viewer one user here, same password, that's 1 2 3 4, for example. So you have two users, and in Grafana you are able to add permissions based on the role. So for example, you can add users with that viewer role, so those users are only able to view the dashboards, the panels. But for more complex permissions managing, you need to add folders for that. So for example, new test 5 folder, and then we are able to move that test dashboard. We are able to move that test dashboard to the we can't just do it like that, but we can move it here to the test 5 folder. So right now we have that dashboard, that test 1 dashboard in test 5 folder, and then we can go to folder and set proper permissions. So as you can see, those are the default permissions, but if you don't want every user that is member of that viewer group to be able to see those dashboards in that folder, you can just erase those additional rows and add, for example, users here. You can also prepare some additional role for that. So as you can see, it's really flexible, that approach. And also you can see it that we are filtering users in that Lua script. So I'm using it in my Nginx reverse proxy, but you can also do the same. So you are able to filter those users that are able to log in from outside. So here in that example, only masters of the code user and viewer users are able to log in. And of course, the admin user is not able to log in. So it's the additional layer of the security, because for that admin user, I'm still able in my configuration to use, for example, VPN to connect to my local area network, and then use Grafana without that Nginx proxy. And for other purpose, for logging from outside, I'm additionally protected because nobody can log into my admin user that way. So that's it for that video. I hope you enjoyed it. If you hadn't already subscribed my channel, now is the time. Also remember to hit the bell icon to get notified about my future videos. Thank you for watching. Bye.